trigonometric ratios. Now in grade 10, or maybe even earlier, you were introduced to some trigonometric ratios, and typically what you will be introduced to are these ratios right here. So cos, sine, and tangent. So these ones right here. Now, if you want to be able to kind of review this material, although I will, I guess, reintroduce them here, I'll put up a link up above there. I think it's worthwhile for you. Now, these are just simply ratios within right-angled triangles. Now, we do utilize the ratios in various other ways, and they don't have to be right-angled triangles. And there's different laws like sine law and cosine law. There are different applications that you can use these with. But ultimately, when you're studying this, in particular, kind of in grade 11, it's going to lead you slowly to try to graph and realize that these can also be functions in some way. Now, I'm going to go over these particular ratios. So there's actually 6 of them. 3 of them maybe you haven't seen before, but they won't be that difficult to try to understand if you understand what a reciprocal is for fractions. Now, remember that trigonometric ratios are simply a ratio between the different sides that we have in a triangle. So here is a right angle triangle. I kind of drew it up on the x and the y axes, and you'll see that as you keep studying why that x and y is going to be kind of important. And there is an angle that is an acute angle within here that we have. And now we want to be able to see different ratios and define these different ratios with these special words that we use, like cosine and sine and cotangent. And now, okay, these ones which are in pink, which you see there, which stand for secant, cosecant, and cotangent. So let's start again at the beginning. So if you have an angle right here, and you wanted to be able to define this angle with respect to some ratios, with some special sines, cosines, and tangent, then this is how we have actually defined them. So what we said is, we have, with respect to this angle, we have an opposite side, which has a certain length. We have an adjacent side, so adjacent to that angle, again, and I'm referring to this opposite adjacent as simply as the lengths of those sides. And then we have a hypotenuse. Now that hypotenuse we can always find through just simply Pythagorean theorem, dating back all the way to elementary school. So we define these with respect to every angle in these right-angled triangles. So opposite, adjacent, and hypotenuse. And now we have these special definitions, all right, with respect to what we say is that the sine, which we write simply as sin for short, of the angle, okay, theta, is equal to the ratio of your opposite, okay, length divided by simply your hypotenuse. So opposite over hypotenuse. So that is how sine, okay, of the angle is defined. So it's just simply a ratio that we can write. Now, we also can define cosine. So cosine of an angle is defined as the ratio. Now, in this case, it's the adjacent side, okay, when we compare it and we divide it by the hypotenuse. And finally, with these, okay, so once you have these two, we can also define the tangent, and that is of that angle, and that is simply equal to the opposite over adjacent. So it's opposite over adjacent in terms of that particular angle. Okay, so that's those ratios that we have. Now, I will mention, okay, which I think is kind of worthwhile mentioning here, notice that tangent, really, if you take the sine and then the cosine and you divide those two, so if you say sine of the angle divided by the cosine of the angle, this just equals to tangent of that angle. And notice, because if you take these particular ratios, well, what is sine? So sine is opposite over hypotenuse divided by, okay, now what is cosine? Cosine is adjacent over hypotenuse. And these are just simply ratios, so they're just some numbers. The hypotenuse itself is going to fall off, and all you're going to get is opposite over adjacent, which indeed is the tangent of an angle. So those are the definitions of these trigonometric ratios. Ratios because we're just comparing the lengths of sides. And now any similar triangle is going to have exactly the same angles, and therefore they're going to have exactly the same ratios. So that's why you were studying similar triangles, for instance, and trying to see which ones are similar. Now, what are these new kind of secant, cosecant, and cotangent? Well, it turns out that sometimes they're useful. To be honest, I actually typically don't utilize them that much because I don't like memorizing things more than I have to. So within these ratios, it's easy for me to try to memorize these opposite, adjacent, and hypotenuse. But, okay, if you wanted to find out what the actual secant and what the actual, okay, cosecant and cotangent are, I'm going to add a page here, then you can certainly do so by simply doing the following. So cosine of an angle we know is adjacent over hypotenuse. Now, if you're going to take the reciprocal of this ratio, because it is just simply a fraction, now if you take the reciprocal, you're going to get hypotenuse over adjacent. And it turns out that that ratio we call the secant of the angle. So it's just simply the reciprocal. So if you notice right here, so this is cos of the angle, and this is the secant of the angle. And they're just simply swapped. So all you do is you just take the reciprocal. So if you know one, so for instance, if I know the cosine, okay, of an angle, then what I can say is that the secant of that angle is just simply 1 over the cosine of the angle, because that's what the reciprocal is, right? If we put cosine of theta, which is adjacent over hypotenuse, which is that ratio, and we substitute it inside for cosine of theta, then what we're going to get is we're going to get 1 over, and then it's adjacent over hypotenuse. Now this is just a fraction, which just equals hypotenuse over adjacent. That's just knowing your fractions. So that is how the secant of an angle is defined. Now, on your calculators, because you may remember kind of from grade 10 or maybe from grade 9 when you were working these out, you may not always find the secant, okay, button. And that's why it's kind of useful to be able to remember that they're just reciprocals of each other. Okay, that secant is the reciprocal of the cosine of whatever angle that you have. Now, the same thing happens with the other ratios. So sine theta, which we know is opposite over adjacent. Now, if you take the reciprocal, I apologize, it's opposite over hypotenuse. And if you take the reciprocal, it's just simply hypotenuse over adjacent. And that's how cosecant is defined. And we write it for short in this way. And cosecant, okay, so this is how it is spelled. And secant right here, if you want to know, okay, so this is how you would spell it, but we don't typically write it out in full. We just write the shorthand. So again, it is just reciprocals. So sine and cosecant are just reciprocals of each other. And once again, what you can do is you can simply say that if you wanted to know what the cosecant of an angle is, then that is just simply the reciprocal of your sine. And now you can probably deduce from this what the cotangent is. So tangent on its own, so if I were to write out tangent within here, I'll switch the color to make it a little bit more colorful here. So tangent is opposite over adjacent, and if you take the reciprocal, then it's adjacent over opposite, and that is known as your cotangent. Okay, so spelled simply, okay, co and then your tangent like you normally would. So that's what you have. And once again, so if you wanted to know what the cotangent is, the relationship, then you can just simply take the reciprocal of that and put it over 1. So those are the definition of all the different ratios. And this secant, cosecant, and cotangent, yes, unfortunately, it's a little bit more to try to memorize, but just remember that they're just reciprocals of each other. Now, where do we use these things? So let's try to see, okay, so that you can play around with some triangles and then compute some of these things. Let's give it a go. So I have prepared a couple of examples here. So here's one example where we have a right angle triangle. They provide us 2 of the sides, so we know those. And we don't know, I guess, what the hypotenuse here is, but we can certainly find it through the Pythagorean theorem. And now they ask us find all the ratios, okay, with respect to the angle of C, which I guess would have been, right here, okay? So that's that angle that we see there. Now, what are all the different ratios that we have? So I'm going to I'm going to drop the angle sign. I'll just write C. So we have, we can have cos of C, okay? So what is that angle? We want to be able to know what is the sine, okay, of C. What is that ratio? What is tan of C? Okay, we want to know what that ratio is. Now, once you have those ratios, all you have to do is just find the reciprocals, and then you will find, okay, so again, cos, so that's going to be the secant, okay, so we can find that. Sine is the cosecant, we can find that ratio, and tan, okay, or tangent is just the cotangent of that same angle. And there we would have all our different ratios that we would actually need, okay, in order to do that. So those are the ratios that we can find. Now, I don't actually have the hypotenuse, right? So I can find the hypotenuse. So my hypotenuse, kind of squared, is equal to 7 squared plus 12 squared. That's just Pythagorean theorem. So h is equal to, so it's the square root of 7 squared plus 12 squared. And I guess, we'll kind of estimate it. So that little dot, okay, so we estimate. And so what would that be? Okay, so we have the square root, and this would have been 7 squared, which is, I guess, 49, plus 12 squared, which is 144. And that is approximately, let's say, 13.89, okay, rounded to kind of 2 decimal places. So now we have our hypotenuse, or at least the approximation of it. And if we want to be able to now write what all the different ratios are, okay, so let's do it. Well, cos is adjacent over hypotenuse, all right? So now, what is the adjacent angle? Well, the adjacent is 12. These are actually m, so it must be in meters. So I guess this is in meters. So we have, so adjacent is 12 all over. This would have been 13.89. And that is that ratio. Now, you can compute it if you like. Okay, I'll just leave it as a ratio. And right away, I can fill out the secant. So the secant is just hypotenuse over adjacent, so it's just the reciprocal. And in this case, this is what I would get right there. So I can knock off 2 birds with just that 1 stone, okay, in order to be able to find it. Now, for sine, maybe I'll change the color just so that it kind of stands out a little bit. So sine is opposite of the angle over hypotenuse. Well, the opposite, I guess, is the 7. So we have 7 all over 13.89. And therefore, that means that the cosecant is just simply hypotenuse over opposite, which is going to be 13.89 divided by 7. So now I have already 4 of my ratios that I need. The last ratio that I have, which is for the tangent, that's simply just opposite over adjacent. So in this case, so that's opposite over adjacent. That would have been just simply 7 all over 12. And cotangent, therefore, is going to be adjacent over opposite, and that's simply 12 over 7. And notice that in this case, the ratios for the cos, sine, and tangent, if you look at them, they're going to be less than 1. And then the ratios for the secant, cosecant, and cotangent are going to be actually more than 1 because you're taking the reciprocal. So if you actually computed them out. So that is one example of finding these ratios. And you can certainly utilize them as you like. Here is another example that I have. This one is a little bit more maybe challenging in some way. So they give us this triangle and they tell us, okay, so if you notice in here, so they have an alpha 1, alpha 2. But they do tell us that those, the lines, okay, so the triangle, so we have a big triangle and then we have a smaller triangle. So really these are just similar triangles, right? If that line, those two lines are parallel, then it actually means that right here, alpha 1 is equal to alpha 2. And that's just coming in from basically similar triangles and the fact that you kind of created an F, right? So you can remember those angles. So these ones are identical. Now, if that's the case, they're asking us, okay, to find. So they give us what the sine, okay, of alpha 1 is, and then what the secant of alpha 2 is. Now, because alpha 1 equals to alpha 2, then that means those angles are the same. That means that it's actually secant. So here we can write that this is secant of really the same thing, alpha 1, because these are identical. Now that we have those, we're being asked to find all of these different ratios. So the cos, the tangent, the cosecant, and the cotangent with respect to the angle of alpha 1. So let's do that, all right? So far what they gave us is the following. So we know sine of that angle, okay, is approximately, I guess this is what they give us, 0.669. Now, some students might want to right away to try to see, okay, well, I can find out exactly what that angle is, and then once you have that angle, then you can go ahead and then use your calculator, okay, to actually find all of these. Now, let's find these without using a calculator at all, which I think is a little bit more telling of you understanding how to approach these. Okay, well, so first of all, because I know the secant, okay, in this case, then I know that the cos, okay, of that, which is the first one they want me to find, is basically just the reciprocal. So this is going to be 1 all over 1.346, and whatever that might be. You know, you can compute it here, okay? We just want to find the actual ratios. So now I have the first one that they asked for, which is cos of alpha 1. Now they want to know tangent of alpha 1. But wait a minute, I know what tangent is. Tangent of an angle is simply equal to, so if I scroll back up here all the way, and what I mentioned right here is, notice that the tangent is just sine divided by cosine, right? Because it gives us this particular ratio, which is opposite over adjacent. Well, because I have now sine and I have cosine, so in this case, I have my sine of alpha 1 and I have my cosine of alpha 1, then I can just substitute these back in, and what I'm going to get is 0.69 divided by whatever that cosine is. Now, so that is just simply 1 all over 1.346, and that will equal to 0.669 multiplied by 1.346. Now, the other thing that you may notice is that instead of kind of dividing by cos of alpha 1, you could have multiplied by the secant, because the secant is just simply 1 over cos. So within here, okay, so another kind of relation that you can say is that, oh, wait a minute, this is just sine multiplied by the secant of that. Because of the fact that sine alpha 1, notice secant is 1 over cos of alpha 1, which indeed equals to sine alpha 1 over cosine of alpha 1, which is exactly what we used. And you'll get exactly the same thing. So that's tangent. Now, what about cosecant? Well, cosecant is nothing else but simply the reciprocal of your sine. So that's not going to be very difficult. So if I want to know the cosecant of alpha 1, that's just 1 over the sine of alpha 1, which is 1 over 0.669, okay, approximately. And finally, cotangent. So for cotangent of alpha 1, well, that's just 1 over the tangent of alpha 1. But I already have found this, okay, right here. So I can just write it 1 all over, and this is going to be 0.669 times 1.346. Now, you can compute all of these. If, for example, if this was a test question and your teachers wanted you to actually compute it, I was actually more interested in trying to show you how these ratios are related and, you know, gave you kind of similar triangles to think about. Because that's what these trigonometric ratios are. They are ratios. They're just a comparison for right-angled triangles, and we've just defined them, you know, sine, cosine, tangent, and then you can take the reciprocals as you like. All right, so thanks for watching, and we'll see you in a future video. Bye, everybody.